Hello guys, welcome you all for this end-to-end session of AIML where you guys gonna learn everything that you guys need in order to become a successful data scientist. Hope you guys are enjoying. We are enjoying and we are learning a lot each and every day, guys. Okay, so hope the same thing for you guys. If you guys stuck anywhere, if you guys have any doubt, just ping in the comment section. We will take up and we will solve your doubt because like we are here to help you. And we're gonna become a person who knows the field of this domain of data science in a very practical manner so that you can work on any kind of things that are present in data science. Okay, so yeah guys, so before going for this session, make sure that you guys watch all the previous session videos because like then only you can able to understand the continuation and understand each and every key terms that we are explaining. Okay, so today's session is all about continuation of Apriori algorithm. Like X-ray session, we have introduced you what is Apriori algorithm, how it works, the steps behind it. Okay, today we're gonna jump somewhat deeper into this algorithm. Let's see what are the things that we are having in the algorithm. And one more thing, guys, please subscribe to our channel and press on the bell icon so that you will be getting whenever we are uploading a video. Not whenever, every day we are just uploading a video so that you will not miss any of our videos. Okay, so yeah, guys. So today we will be diving somewhat deeper to this a priori algorithm. Let us see. Okay, a priori algorithm step by step explanation we have already done with it, but like I need to have a clarity and a continuation of this session so that I'm just starting with the same thing that we have explained in the previous session. Okay, so what are the steps that are involved in the a priori algorithm? It's a kind of association rule. First thing, we need to select a candidate generation. Okay, we need to go for a candidate generation. That is, whenever we are having item set, right, items with us, we need to go for a permutation combination of each and every item. Then we need to calculate its support, that is like a percentage of how much they are occurring. Then we need to go for pruning, that is deletion. We need to fix a percentage, and whatever the value which is less than that, we need to go for a pruning, that is deletion of the items. Finally, we will be end up with the frequent item identification, that is frequent item set we will be having, that is the items that are gonna occur more frequently in the data set. Okay, this is what the steps involved in a priori algorithm. Hope you guys have understand this. So yeah sir, over to you.
Yeah, so the a priori algorithm we will explain by step. So first of all, we have to step one is candidate generation. So the algorithm states generating candidate item sets of increasing size, starting with individual items and gradually building up large data sets. Like it will start gathering the candidates and then increasing its size, and gradually it will build the larger sets. Then we have support calculation, which is for each candidate item set, the algorithm calculates its support, which is the uh, proportion of the transactions that contain that item sets. This determines the frequency of item sets in the data set. So that is the support calculation. And then we have pruning, which is again, it's a word for deletion. So it prunes, it is applied to prune candidate item sets that have infrequent subset, so like which are not frequent. So it depends on the cluster and the class it has in the data set, it so which the subsets we have to prune. And then we have this step eliminates unlikely candidates which are not required, significantly improves the efficiency, and that's why we do pruning. And then we have fourth step in this algorithm, frequent item set identification. After pruning, the algorithm identifies frequent item sets based on support threshold. These frequent item sets represent patterns that occur frequently in the data set. So this is how step by step this algorithm works and behaves. Let's move to the other session.
Yeah sir, let's move on to the next slide. Okay, now we have explained you. Okay, let's move on one by one. Okay, what's the first thing? Generating candidate items. Okay, how we can generate? Let's have a flow. First thing, initialize candidates. That is, algorithm start considering all individual items as a initial candidates. Okay, that is, if we are having 5 items, we will be considering each individual item as a first thing. Okay, like milk, butter, jam, bread, and then chips. Okay, like that, individual item. Then joining candidates. Each iteration, in each iteration, the algorithm joins candidate item set of size k to generate the candidates of size k plus 1. The joining process involves combining item sets that shares k minus 1 common item. Simple. Okay, let's put this way, very very simple. What is joining candidate sets? You are having 5 items, right, as of us. Okay, now we have done with one item, go for a second 2 items. Okay, milk butter, milk jam, milk chips, like that, and then chips jam, chips milk, like permutation combination. Then go for 3 items, milk butter biscuit, biscuit milk, like that, go for 3 different combinations, then 4 different combinations, finally end up with 5. Okay, 1 2 3 4 5, that's a permutation combination that you guys need to do till this point. Okay, initial item, single items, joining candidates, till n that you are having, pruning. Okay, sir has explained simply, it is a deletion. Okay, after joining, the algorithm applies a priori principle to prune candidate items that have infrequent substance. Okay, when the support is very less for any one of the combination, we're gonna remove that. That is called as pruning. Okay, simple. Initial candidates, joining candidates, and pruning. That is called as generating candidate item set. Hope you guys have understand. Okay, so yes, sir, over to you.
Yeah, generating candidate item sets. The step one, we have 3 steps. So initial candidate. So algorithm starts by considering all individual items as initial candidates. That's the very simple statement. So then step two, joining candidates. It in each iteration. So the algorithm joins candidates item size by K. We have learned about, guys. K means clustering algorithm. So you understand what is K. To generate candidate size, K plus 1. So this joining process involves combining item sets that share K minus 1 common item set. So it's like it will do plus minus. So according to if it is if it is it is generating candidate, so it will be k plus 1. If it is joining, involves combining item set that share k minus 1 common, so it is going to create kind of clustering, guys. The k plus 1 is a separate uh, generating candidate size, and the other one would be k minus 1. And then we have pruning, which is deletion. So after joining the data sets, so item sets, so the algorithm applies the a priori principles to pruning. Prune the candidate item size that have infrequent subsets. So that this is how, with simplicity, these 3 steps are involved in generating candidate item sets. So this is how it behaves, guys. So keep learning with deep and long-term objective function, and with patience, persistency, consistency, and perseverance. So keep learning deeply at a meta level, all these concepts. So absorb the information, digest the information, and apply the information. Do all the quizzes, keep learning. Let's move to the other section.
Yeah, sure, sir. Let's move on to the next thing. Okay. Okay. Computing support and confidence. Guys, if you guys watched all our videos, like I think 3 sessions before or 2 sessions before, we have explained this. Okay. No problem. We will explain again. Okay. How to compute the support and confidence. Support is a measure of how frequent an item set occurs in the data set. It is calculated by dividing the number of transactions containing the item set by the total number of transactions. This represents the popularity of the item set in the data. Putting in the simple way, if we are having 10 transactions and in all transaction milk is present, then what is the support of it? 100%. Okay, simple. How many times the item occurs divided by total number of transactions. Okay, that is what called as support. What is the confidence? Confidence measures the probability that an item set B will occur given that another item A has already occurred. This is calculated by dividing the number of transactions containing both A and B by the number of transactions containing A. This represents the strength of relationship between A and B. Okay, consider. Let's break it up. Okay, because like I hope like it's a bit confusing. Let us break it up. What is mini confidence? Simple. We are having 2 different items. One is milk, another one is biscuit. Okay. milk and biscuit. Okay, we need to find how many transactions which has both milk and biscuit, such that divided by whenever there is a milk. Okay, that is called as a relationship between the milk and biscuit. This is what called as confidence. We need to find a relationship between two different items or multiple items. That is called as confidence. Okay, hope you guys have understand. Support is the frequency of the item present in the all the transaction. Confidence is a relationship between the items based on the occurrence of two items based on the one item which occurs already. Okay, hope you guys have understand. Support means frequency item finding, confidence means relationship finding. Put it in the simple manner. Okay, so this is what called as support and confidence. This is how we can calculate support and confidence. Okay, this is another step, guys. Okay, because like we are explaining you, right, we need to delete whatever the item set that has the minimum confidence or minimum support. This is how we can calculate it. Okay, so you guys now understand the black box, right? Now let us move on to the next thing. Okay, what we are having next, let's see. Perfect. Now identifying frequent item set. Okay, this is what, guys, let's see. Item set support, what is a frequent? Milk, bread, support is 0.5. Milk, egg, but bread, support is 0.2. Milk and cheese, 0.1. Let us consider our support should be greater than 0.1. That is considered as a frequent item. Now, milk and bread has a support of 0.5. Then it is a frequent item. We can click it as yes. Milk, egg, bread, we are having a support of 0.2, which is greater than 0.1. Okay, we can fix it as yes. But milk and cheese, it's 0.1, which is not reaching our threshold. It should be greater than 0.1, but it is equal to 0.1. So we are just putting as no. This is how a priori successfully creates a frequent item set. Now these two are only the frequent item set, that is milk and bread. Whenever a person comes to a shop and buys milk, suggest them to buy the bread or keep the bread somewhere very near to the milk so that they can buy. Okay, if the data set belongs to your shop, okay, you guys should not ask me, okay, I have tried for different shop whether it's gonna be work for my shop. No, you need to collect the data set of your shop and you need to create a priori algorithm on top of it. You need to find the candidate set, you need to find the support of each and everything, and then you need to prune it, and then finally you create the item set based on the item set you are getting for your data set. This is what the support, so that you can keep the product very near to. Based on this data that we are having, whenever you are having milk, right, keep the bread near to it, because there is a 50% chance of a person buys a milk, then he or she gonna buy the bread. Similarly, if the person is gonna buy milk, egg, then the possibility is 20% they will buy the bread. Egg, bread, there is a 20% possibility of buying the milk. Milk, bread, there is a 20% possibility of buying the egg. Guys, you need to consider all the things. If any two is buy, next one is more likely to buy, like that. Okay, permutation combination. But like, don't keep cheese within the circle of milk, because it's not gonna give you money. Okay, that's the bad strategy, because like for that we are having only 0.1, 10% of chance. Just remove it. Okay, try to have these three things more closer: milk, egg, bread, so that your sales will be increasing. Okay, this is the end game of a priori algorithm. You will be getting the frequent set like a table format. From there you can have a strategy and keep the items closer so that you can increase the sales. Okay, let's move on to the next slide. Okay, yeah, we are having applications and real world examples. Okay, I hope like we have already discussed these things when we are going for association rule, but like let us touch one more time. Okay, market basket analysis. I hope like, I don't know how many times I just pronouncing this word, like it will be more than 10 to 20 times. Okay, okay, what is meant by market basket analysis? Simple. We need to identify the products that are frequently purchased together to optimize the product placement, develop target marketing campaign, and create personalized recommendation. Simple. Okay, this is what we are just learning each and every day. Okay, related, whenever we started with the association rule, we are learning this market basket analysis. We need to find frequent items that are occurring together, so that we can ask the shop owners to place the items very nearer to each other, so that the customer can buy it. Okay, based on our strategy. Okay, they can improve the sales also. Next. Social network analysis, discovering a group of users with shared interest and behavior, identifying influential individuals and understanding community dynamics. Okay, if you guys are following us, okay, then what is the social network between us? We all are data science. Okay, we are all not data science, we are all learning data science. So this is what the network. Okay, we all learning data science, so any materials related to data science will pop up in YouTube, in LinkedIn, wherever you go, in Google, everything. Okay, that is called as social network analysis. Let's move on to the next application, that is called as medical diagnosis, identifying patterns in patient data to assist in diagnosis and treatment planning, leading to the improved healthcare outcomes. Consider, guys, this is very sensitive thing, because like in healthcare, this recommendation system works in I will say, this is a breakout, guys. Okay, I will say this is a breakout, and this is an achievement of data science field and this association rule creation of recommendation system, right? Whenever a person comes with a disease, a recommendation system or a priori algorithm try to create association rules. Okay, these are the things due to which this happens. When a patient comes, when another person comes with the same kind of symptoms, then it will be very easier for that patient to be diagnosed, because already we have a strategy of how to diagnose a person or a patient who has this kind of diseases or this kind of symptoms. So these are the strategies. So before itself we will be having these are the symptoms, and these are the strategies we need to fix these symptoms of the person. So whenever a person, another person comes with the same symptoms, it is easily, we can easily recommend them to have these kind of treatments so that it will be diagnosed. Okay, guys, it's a sensitive field, it's an achievement for us. Okay, whenever we are learning data science, recommendation system is one of the achievement for us. So which is gonna help in every field, very sensitive field like medical. Okay, next, fraud detection, identifying unusual patterns in the transaction and user behavior, leading to the early detection and prevention of fraud activities. Okay, whenever we are transaction, right, whenever we are transacting money kind of thing, there, if there occurs some kind of fraud, if similar patterns occurs in the next time, the transaction will be stopped there. So our money gets saved. Okay, so this kind of recommendation will also occur. So guys, these are the things, these are the base recommendation systems that are built and their applications in the real world, like market basket analysis, social network analysis, medical diagnosis, fraud detection. Not limited to this, there are n number of applications which is available, guys. Okay, so yeah, these are everything about today's session, guys. Hope you guys have enjoyed the session, because we have learned of algorithm, that is a priori algorithm, in the previous session and today's session, and we have completed it. It's a base algorithm of association rule, which is based for all kind of recommendation system that we are having today. So yeah, guys, this is all about today's session. Hope you guys have enjoyed this session. If you guys have any doubts, just ping us in the comment section, we'll take up and we'll solve your doubts. Okay, so yeah, guys, this is all about today's session. Hope the session is very informative. Okay, and one more thing, guys, if you guys doesn't subscribe to our channel, please subscribe to our channel, because like every day we're gonna post a new video, and also like press the bell icon so you'll be getting the notification whenever we are uploading a new video. So yeah, guys, thank you so much, guys. Thank you for your time. Keep learning, keep enjoying what you learned, and try to apply anywhere. And if you have any doubts, come here and we are here to help you. Okay, so yeah, guys, keep learning, keep enjoying. So we all meet in the next session. Until next session, bye, guys, take care. We will all meet in the next session. Bye, guys.